So we need to start with the bearing. From the south, go 31 degrees towards the west. So let's say here's south, and then go towards the west. And this is 31 degrees. And next, she turns 90 degrees to the right, so that would be going this direction. 90 degrees right there. And that is said to be a bearing from the north. So the north line would be like this. From the north, go 59 degrees to the west. And this was 4.5 miles. And the second part of the run was 6 miles. So find the distance and bearing back to the start. So here she is, and then going back to the start of the run would go this way. So because of this, we have a right triangle, and we can solve for the distance back just using the Pythagorean theorem. So we've got a triangle that looks basically like this, with a 4.5 and a 6 and an unknown. So we can just use that x squared equals 6 squared plus 4.5 squared, and then take the square root of that. So the square root of 6 squared plus 4.5 squared. Well, that worked out nicely. So it's going to take 7.5 miles to run back to the start. So there's the distance back to the start. And now, what bearing should she take back to the start? Well, the first thing to do is find this angle. So basically, when she turned right again to go back, what angle was that? So that I can also put over here. And if I use these two sides to help find the angle, then that's going to be opposite and adjacent, so use tangent. So tangent of theta is opposite over adjacent. And then find tangent inverse. So tangent inverse of a 4.5 divided by 6 is 36 point, let me change that back to 3 decimal places, 87 degrees. And we're nearly finished. We have the angle, but that's not actually the bearing, because bearing means go from a north-south line. So if we drew a north-south line like this, then we need to be able to say from the north, go this many degrees towards the east. Or from the south, go this many degrees. Which means that we need to know, if I were going to go from the south line, we need to be able to go from the south line right here all the way over to that, which is our line back to the start. And we do have this as 36, but we're missing this part. And this part right here is actually 59 degrees, because when you have two parallel lines and what's called a transversal, then alternate interior angles, like this one right here and this one right here, are going to be the same size, or congruent. So that means that as you cross this transversal, this has to be 59 degrees in here. So then finally for the bearing back to the start, we would take the answer we got and add 59 degrees. And so from the south, she should go 95.87 degrees towards the east.